Last week, the AI world experienced one of the most explosive weeks in history. It was no coincidence that 4 tech giants simultaneously dropped bombs in the same period of time. Meta just created eyes for robots that can see and understand the world like humans. Google shrunk AI down to the size of a pea but still be as powerful as a monster. ByteDance taught AI to become super code bug hunters. And Microsoft? They just created a new DNA for how we communicate with AI. But most importantly, these are not 4 separate events. These are 4 pieces of a much larger puzzle. Why now? Why are we seeing this explosion? 3 reasons. First, the AI race is shifting from bigger to smarter. GPT-4 and Claude have demonstrated raw power. Now the question is, how do we make AI work in the real world? Second, edge computing revolution. 5G dedicated AI chips and battery technology are mature enough for AI to run directly on devices without the need for cloud. Third, real enterprise demand. Companies no longer want AI demos. They want AI that solves specific problems, has measurable ROI, and can be deployed today. Today's 4 breakthroughs represent 4 missing pieces. Vision AI, Meta, Eyes for Machines, Edge Intelligence, Google, Compact Brain, Code Intelligence, ByteDance, Expertise, Prompt Engineering, Microsoft, Language of Communication. When combined, we have a complete AI system that can see, think, work, and communicate effectively. This is the foundation for the next wave of AI applications. In today's video, I will deep dive technical, not just the what, but the how and why real-world demos, actual code, actual numbers, actual results, business impact, ROI calculations, cost analysis, timeline adoption, hands-on guidance, exact steps you can try today, future convergence. What do these 4 technologies become? Let's dive in. 1. Meta Dino of 3, the universal I-core problem. Currently, computer vision has a fundamental problem, data dependency bottleneck. To train an AI model to recognize 1,000 objects, you need 1,000 categories, x 1,000 images, category, triers, 1 million images, 1 million images, x 30 seconds labeling, Warner 8,333 hours human labor, 8,333 hours, x 15-hour yarn, $125,000 just for labeling, and that's just 1,000 objects. The real world has millions of objects, variations, contexts. Dino of 3 solution architecture self-supervised learning revolution. Dino of 3 learns in a completely different way. Instead of human-labeled data, 1. Massive unlabeled ingestion, 1.7 billion images from internet. 2. Pattern discovery, AI 2 team similarities VOD differences. 3. Representation learning, TAO, universal understanding of visual world. Technical innovation, frozen backbone. This means, train once, use everywhere. No retraining for new tasks, computational cost stays low, consistent performance across domains. Performance numbers that matter, accuracy, comparison, YOLOV 8, 83.2% map after domain-specific training. Detectron 2, 85.1% map after domain-specific training. Dino 3, 87.4% map, 0 fine-tuning. Speed comparison, inference time. VITB variant, 15 ms image, mobile devices. VITL variant, 45 ms image, edge servers. VITG variant, 120 ms image, cloud servers. Memory footprint, VITB 400 MB RAM, VITL 1.2 GB RAM, VITG 3.8 GB RAM. Real-world case studies. Case 1, NASA Mars Rover Challenge. Identify rocks, terrain features without Earth-based training. Solution, Dino of 3 VITL running on rover's edge computer. Results, 40% improvement in autonomous navigation decisions, 60% reduction in safe mode incidents. Operates 4 hours longer per sol due to computational efficiency. Case 2, Kenya Forest Monitoring Challenge. Measure tree canopy height for carbon credit verification. Previous accuracy, 4-point minimum average error, too high for carbon trading. Dino V3 results, 1.2 average error, 70% improvement. Business impact, 2.3 in additional carbon credits qualified for trading. Hands-on demo. Try it yourself. Code walkthrough. Installation. Basic usage. Real example, security camera. Performance monitoring, inference time. 50 memas on RTX 4090. Memory usage, 400 MB. RAM accuracy on security dataset, 94.2%. Business applications, ROI analysis for different industries. Manufacturing quality control. Setup cost, $50K. Cameras plus edge computers. Dyno V3 integration. Additional $5K software development. Human inspector replacement. $80K year salary. X 3 shifts. SOX 240K year ROI. 336% in first-year retail inventory management. Traditional barcode scanning. 2.3 seconds item Dyno 3 visual recognition. 0.1 seconds item productivity gain. 23x faster. Cost savings. 180K year for 1,000 SKU store. Medical imaging. Radiologist time saved. 40% faster. Preliminary screening. False positive reduction. 23% fewer unnecessary procedures. Patient throughput increase. 35% more scans per day. 2. Google Gemma. 3. 270 Maze, the Pocket Genius. The Edge AI Revolution. Why Edge AI matters now. The Cloud AI Tax. API costs. 0.002 0.02 per 1K tokens. Latency, 100-500 millimeters round trip. Privacy risks, data leaves device. Connectivity dependency, no internet. No AI. Edge AI benefits, 0 API costs after initial setup. 10 ms latency, complete privacy, works offline. But until now, Edge models sucked. Tiny models, MAR, toy performance. Gemma 3 270 MHz changes this equation completely. Architecture innovations. 1. Massive vocabulary efficiency. 256K token vocabulary versus typical 32K. Handles rare technical terms without fallback, especially strong in medical, legal, engineering terminology. 2. Quantization-aware training trained, knowing it would run in 4-bit precision. No post-training quality degradation, full precision, 270 MHz parameters. Quantized, 68 MHz parameters, 4x compression. 3. Instruction, following architecture, pre-trained, plus instruction-tuned versions, follows structured prompts out of the box. Fine-tuning, 10-20 examples versus thousands typically. Task-specific performance, code generation, human eval, Phi 3, Mini 61.2%, Gemma 3 270 meets 42.1%, impressive for size. Reasoning, GSM 8K math, Phi 3 Mini 82.5%, Gemma 3 270 meets 68.9%, summarization, CNN, Daily Mail, Gemma 3 270 meet 28.1%, Rouge L, competitive with much larger models. Device performance tests. Pixel 9 Pro. Results, 25 full conversations, 0.8% battery drain. Average response time, 1.2 seconds. Cold start time, 0.3 seconds. Memory footprint, 180 MB persistent. iPhone 15 Pro results, via Core ML. Similar battery performance. Slightly faster inference, A17 Pro optimization. 165 MB memory footprint. Enterprise applications that make sense. 1. Compliance checking. ROI. Legal review time reduced 60%, 200K year savings for mid-size firm. 2. Customer service triage. ROI. 40% faster ticket resolution, 25% fewer escalations. 3. Personal assistant. No data leaves device. GDPR, HIPAA compliant. Instant responses. Customizable to personal preferences. 0 subscription fees. Hands-on tutorial. Build your first Edge AI app. Step 1. Setup. Step 2. Load model. Step 3. Basic chat interface. Step 4. Fine-tuning for your use case. Performance expectations. Fine-tuning time. 2 to 4 hours on single GPU improvement in domain tasks. 15 to 25% accuracy boost. Memory usage during training. Jartson 4G Galbi VRAM. 3. ByteDance ToolTrain. The code detective. The code-based nightmare. The scale problem. Modern software projects are massive. Typical enterprise code base: 2 to 5 million lines of code, 500, 2,000 files, 50, 200 developers contributing, 20, 50 bugs reported daily. The bug hunt problem: when a user reports login button doesn't work on mobile, developer needs to identify which component handles login, find mobile-specific rendering code, check authentication flow, examine error handling, trace through 515 interconnected files. Current tools fall short. grep, search, too many false positives, IDE, navigation, requires knowing what to look for. LLMs get lost in large contexts, make wrong assumptions. Traditional debug time: simple bugs, 2 to 4 hours average; complex bugs, 8-32 hours average; critical production issues, 4-12 hours, with multiple developers. ToolTrain architecture revolution: the two-stage training approach. Stage 1, rejection. Sampled supervised fine-tuning train on successful bug-finding sequences. Learn when to use each tool, search, analyze, trace. Reject failed reasoning paths during training. Stage 2, tool-integrated reinforcement learning reward. Correct tool usage sequences. Penalize inefficient exploration. Optimize for multi-step reasoning. Accuracy. Available tools: 1. Function locator, find function definitions by name. 2. Call graph tracer, follow function call relationships. 3. File content analyzer, understand code context. 4. Symbol reference finder, track variable, class usage. 5. Git history analyzer, understand recent changes. Benchmark deep dive SWE bench verified results. Function level recall 5. Finding the right function in top 5 guesses. Why this matters: 7B model beats much larger general models. 32B model achieves enterprise-grade performance resolution rate. Actually fixing the bug, not just finding it. Real-world performance analysis case study. E-commerce platform. Bug report. Checkout fails on Safari when using PayPal. Traditional approach. Senior developer. Time: 6 hours. Files examined: 23 false leads followed, 8 root cause, Safari-specific cookie handling and PayPal integration, ToolTrain approach. Function locator: checkout, PayPal, find payment processing functions. Call graph tracer, follow payment flow, identify cookie dependency. File content analyzer: examine cookie handling code, Safari-specific issue. Git history, recent changes to cookie logic. Confirm root cause. Time: 47 minutes. Files examined: 6 root cause. Same issue identified, 87% time savings. Technical implementation: how ToolTrain makes decisions. Decision tree. Example: bug, user can't upload files, 10 MB. ToolTrain reasoning: 1. File upload, look for upload-related functions. 2. Size limit, search for 10 MB. File size, upload limit. 3. Found upload handler, use call graph tracer. 4. Trace reveals size validator. Use file content analyzer. 5. Size validator has hard-coded 10 MB limit. Root cause found. Traditional LLM reasoning. 1. This might be a front-end issue. Searches UI components. 2. Could be server configuration. Examines nginx config. 3. Maybe it's database storage. Checks DB schemas. 4. Eventually stumbles on upload code after hours of exploration. The training data quality: 12,000 verified GitHub issues. Each issue verified by professional developers. Multi-step reasoning paths labeled failed approaches marked as negative examples. Hands-on setup: getting started with ToolTrain. Installation. Basic usage. Integration with IDEs, VS Code extension. Command line interface. Business integration. Jira integration. Auto-investigate new bug reports. GitHub integration. Analyze PRs for potential issues. Slackbot. Developers can ask questions about codebase. ROI calculation for development teams. 10 developer team savings. Average debugging time reduced. 65% bug resolution time, 4.2 hours, 1.5 hours average. Developer time saved, 27 hours, week annual savings, $180,000 at 75-hour developer cost. ToolTrain setup plus maintenance cost, $25,000 year net ROI, 620%. 4. Microsoft POML, the AI communication protocol, the prompt mess problem. Current state of prompt engineering, what most prompts look like today. You are an expert financial analyst. Analyze the attached quarterly report and provide insights on revenue growth, expense management, and market positioning. Focus on year-over-year comparisons and highlight any concerning trends. Output should be exactly 500 words, formatted as executive summary with bullet points for key findings. Include specific numbers and percentages. Be objective and professional. Avoid speculation. Use the data from Q3 2024 report.pdf attached below. Here's the data, giant wall of text. Problems with this approach: hard to read and maintain logic mixed with formatting requirements. Difficult to reuse parts. No version control or collaboration. Breaks easily when modified. No way to test variations systematically. POML, the structured solution. Same prompt in POML. Immediate benefits: readable and self-documenting logic separated from presentation. Reusable components. Version control. Friendly. Easy to modify and test. IDE support with auto-completion. Advanced features, templating and dynamic prompts. Variables and loops. Conditional logic. Component reuse. IDE integration and developer experience. VS Code extension. Features: syntax highlighting for POML tags. Auto-completion for standard elements. Live preview of rendered prompts. Built-in testing with different models. Version control integration, collaborative editing. Testing framework. Multi-model testing. Real-world implementation enterprise prompt. Library, team collaboration, shared prompt libraries, version control integration code review process for prompt changes, A/B testing framework, performance analytics. Business impact, ROI for prompt engineering teams. Before POML, average prompt development time, 4 hours. Testing variations, manual, 8 hours per iteration. Maintenance, 2 hours per modification. Team collaboration, difficult, lots of duplicated work. After POML, average prompt development time, 1.5 hours, 62% reduction. Testing variations, automated 30 minutes per iteration, 93% reduction. Maintenance, 20 minutes per modification, 83% reduction. Team collaboration, seamless, shared libraries. Enterprise case study, company, e-commerce platform with 50+ AI-powered features. Before, 3 full-time prompt engineers, 2-week iteration cycles. After, same team manages 3x more prompts, 3-day iteration cycles. Cost savings, $200K a year in engineering time. Quality improvement, 40% fewer prompt-related bugs in production. Getting started guide. Installation. Your first POML prompt. Running the prompt. Five. Convergence. The future unified system. The big convergence. When all 4 technologies combine. Imagine an AI system with 4 capabilities. 1. Dino of 3 vision. See and understand the real world. 2. Gemma 3. Edge intelligence. Think fast. No need for cloud. 3. ToolTrain code intelligence. Understand and fix code like an expert. 4. POML communication. Structured and efficient communication. Real-world convergence scenarios. Scenario 1. Autonomous software development robot. Performance expectations. Bug identification. 3 times 5 minutes versus 2 to 4 hours human. Fix implementation. 10 times 15 minutes versus 1 to 3 hours human. Success rate, 78% for medium complexity bugs. Total cost, $0.50 per bug fix versus $150, $400 human developer time. Scenario 2, Smart Factory Quality Inspector. The unified system, business impact, quality detection accuracy, 99.2% versus 94.1% human inspectors. Inspection speed, 50 UX faster than human false positive rate, 0.8% versus 5.2% human. Annual savings for mid-size factory, 2.E mounts. We are living in a unique historical moment. These 4 breakthrough technologies are more than incremental improvements. They represent fundamental shifts in how AI systems will work and integrate into our everyday lives. The companies and individuals who understand and adopt these technologies early will have significant competitive advantages. But more importantly, we need to ensure that these advances benefit everyone, not just a few. Let's start experimenting, learning, and building. The future of AI is not something that happens to us. It's something we actively create. Key takeaways. Vision AI is ready for production use. Edge AI makes powerful AI accessible everywhere. Code intelligence will transform software development. Structured prompting is essential for reliable AI systems. Integration of all 4 will unlock unprecedented capabilities. The question is not whether these technologies will change the world. The question is, will you be building the future or just watching from the sidelines? Let me know in the comments which technology you are most excited to try. And don't forget to subscribe so you don't miss the next AI breakthroughs.